Okay, let's dive right into this explainer. We're going to completely demystify the foundational language of modern computing today. Look, if you've ever stared at a screen full of code and felt, completely overwhelmed, don't worry. Honestly, we've all been there. Our goal right now is to break this down so clearly that you're going to be able to read code without hitting the panic button. So I want you to take a second and think about the hidden architecture of the software you use every single day. I mean, from the core of the smartphone in your pocket to the incredibly complex software driving the Mars rover millions of miles away, what is the underlying language that actually powers so much of our modern world? The answer? It's the C programming language. It was developed way back in 1972 by Dennis Ritchie at Bell Labs, originally to build the Unix operating system. Now, you might be wondering, why on earth is a language from the 1970s still so wildly popular today? Well, it's because it gives programmers maximum control and efficiency. Put simply, C talks directly to the computer's hardware without any middleman getting in the way, making it absolutely lightning fast. It is literally the bedrock of modern computing. Here's our quick roadmap for today. 1. We'll meet the C language. 2. We'll cover the code translator, compilers. 3. The anatomy of a C program. 4. Your very first program. And 5. The building blocks, C functions. Okay, Section 1. Meet the C language, the foundation of computing. At its absolute most basic level, computer programming is simply using a language like C to create a list of instructions for a computer to follow. That's really it. You are basically just writing out a to-do list for a machine. And I absolutely love this quote from our source material because it's so reassuring. It says, C is an easy language to learn. It is a bit more cryptic in its style than some other languages, but you get beyond that fairly quickly. So if you look at C right now and think it looks like alien math, hey, that is completely normal. Once you grasp the core logic and the basic grammar, it actually becomes highly understandable. Moving on to Section 2, the code translator, compilers. So how does the computer actually understand what we're typing? Well, a C program requires a specific tool called a compiler. You see, the source code we write is human-readable. But your computer's brain, the CPU, doesn't speak our language at all. It only speaks raw machine language. A compiler acts as a mandatory human-to-machine translator. Basically, a compiler bridges the massive gap between human logic, which is saved in text files ending in .c, and the raw computer processing of executable machine language. Without it, our typed instructions are just useless text sitting on a screen. Which brings us to Section 3, Anatomy of a C Program. To truly understand a program's skeleton, let's first look at its punctuation. Let's remove the mystery behind those strange symbols beginners always seem to stumble over. First up, curly braces. Every single C program uses pairs of curly braces to mark out a block of instructions, basically grouping them together. Second, the semicolon. Now in C, a semicolon acts as a statement terminator. It's exactly like a period at the end of an English sentence. It just tells the compiler, hey, I am done with this instruction. Now look at the fundamental structure of this program. Notice the word main followed by those parentheses. Every single C program out there, no matter how ridiculously complex it is, must have one and only one function named main. This is the absolute starting point. When you run a program, the operating system literally calls this main function to kick things off. And notice those curly braces right underneath it? Everything inside those braces is the body of the program, the actual instructions the computer is going to execute. Let's put this into practice in Section 4, your first program. We're going to read this step by step, just like a real programmer does, so you aren't hit with a giant wall of text. Step 1 is the preprocessor command right at the top, #include stdio.h. This simply tells the compiler to bring in the standard input and output tools before doing anything else. Step 2 is our start point, int main with parentheses. We know this is where the action begins. Step 3 is our actual instruction, printf, followed by let's learn C programming in quotes and ending with our trusty semicolon. This simply prints those words to the screen. And finally, step 4 is the finish line, return 0. This sends a 0 back to the operating system, which is just programmer speak for, hey, everything ran perfectly with 0 errors. See? When you break it down like that, it makes complete logical sense. Now for our final concept, Section 5. Building blocks, C functions. So how do simple programs scale up into massive pieces of software? They use functions. Think of a function as a reusable Lego block. It's just a self-contained block of statements grouped together to perform one specific coherent task.
By breaking a huge problem down into dozens of smaller functions, reading, debugging, and testing your code becomes incredibly easy.
All programs are built from functions branching out. At level 0, right at the very top, we have our main function, our starting point. But instead of cramming thousands of instructions into main, it branches out. Main might call function 1, 2, 3, and 4 at level 1, and then those can call even more functions down at level 2. The entire program is really just a beautifully organized collection of these functional Lego blocks passing control back and forth. So the next time you hear someone talking about the insane complexities of C programming, you'll know that beneath the surface, it's really just a logical system of basic building blocks. You start at main, you group your instructions with curly braces, you end them with semicolons, and you use a compiler to translate the whole shebang for the machine. It's elegantly structured. Armed with this map, you aren't just looking at random text anymore. You're looking at the exact language used to build operating systems, space shuttles, and the modern internet itself. The only question left is, what will you command